let us see an application of pointers and see how useful it is. For that, we can take a simple example of swapping of two numbers or two integers. Say there are multiple ways of doing it. Let us do it using functions. We will do it using functions, but without using pointers. So first we will do it like this, that we will create a function for swapping of two numbers, but we will not use pointer. Then we will use pointer and see the difference between the two, and we will come to know the importance of pointers also. So let us say I write a program, write this, fine. So I have two numbers x and y, fine. X contains 10, y contains 20. Okay, these are integers. And then to swap these two, let me call a function, for example, swap, fine. So this function is this is a swap function, and I will pass x and y to this function, and the job of this function is to do the swapping thing. So let me declare this function here. So the function is it is int swap, fine. Or we may keep it as a void function because it will not return anything. So let it be two integers will be passed to it, and this is it. This is the declaration, fine. And now coming here, we define this function void swap, fine. And this function is taking two values. So for example, one is stored in A, another is stored in B, fine. It means that the contents of x will be copied to the contents of to A, and the content of y will be copied to B, fine. So now we have A and B which have to be swapped. A and B are copies of x and y respectively. So to swap, we know the simple way. Let us create a temporary variable. Then the temporary variable, in that temporary variable we store the first number. Then the second, we override the second number by the first number. Then we write the let it be like this, A and B, fine. So we have stored the A in temp, then overwritten A with B. Then we should overwrite B with temp. So this is a common way of swapping. Okay, we are done with swapping. Now let us print the result. So printf is numbers, or let it be like this. This is a percentage d and two numbers. So I had to print percentage d, okay, comma, and we will have to print A and B, fine. So this A and B will be printed, and they have been swapped. A contain 10, B contain 20. Now A will contain 20 and B will contain 10. They will be printed, fine. So let us save this program as swap without pointer.c. Okay, compile and run. So we can see this has been swapped at 20, and now A contains 20, B contains 10. Fine. This is simple. This is good. Okay, let us now see that this 2010 we are printing from this function. So if I do one thing, that I write a code here, I write here printf, right? And I write %d, right? Comma x comma y. So what am I trying to do? After calling the function, all things have been done. Good. Let me put this as a comment. Function has been called, swapping has been done. Now obviously it will return back here, and then this function will be executed printf, and the value of x and y will be printed. Let us see what happens if I compile and run. We see that it puts the original values, that is 10 and 20 here. So what we can deduce from all this thing is that a copy of x and y went to this function, that copy was swapped, and the original x and y was untouched. Nothing happened to the original x and y. They were as such. Even after all the things have been done, x and y remain the same, 10 and 20. So the swapping was done on the copy of x and y, but not on the original x and y. Fine. This is one issue. Another issue, that we created a copy of x and y. So we should have used only 2 integers, but instead we used 4. We created a copy of that thing, right? And to solve this problem, and we should use pointers, right? So let us copy this program and do the same program using pointers, right? So let me create another file, paste it here, change this program a little so that it becomes a program for swapping of 2 numbers using functions and using pointers. Functions as well as pointers will be used. So we have a function main, we have 2 values, then we call a function swap, okay? But this function, when we call this function swap, we don't pass the numbers, we pass their addresses, and because we are using pointers. So we can see here that this is %x, %y. %x here means the address of x. So this function will be called, and the address of x will be passed here, and the address of y will be passed here. Not value, but address. So since address is being passed, so we cannot write int a, we have to write int star a, fine, because this is a pointer. This a is a pointer now, and this star means it is a pointer, and it will store the address of x. In the same way, I can write here star b, which means that the address of y will be put in this thing. That, in other words, b will point to y. So now it is not what is being passed, the address. It is not the value. The 10 and 20 value is not being passed here. It is the address of x and y. Fine. Now we can do swapping, create a temporary integer. In that temporary integer, we obviously need to store 10 initially. So 10 is at address a, so we have to write star a. Here obviously the star means value at a. So value at a will be stored in temp, okay? Then the value at a will be overwritten with the value at b, and then the value at b will store temp. So the logic remains the same. The way of writing is changed. We are done with this. Fine, we have done all the swapping and all these things, and we are printing the result here. Fine, let us see what happens. So let me save this program as swap up using pointer dot c. Then compile and run. It is saying, okay, we have to define this also, this swap here. We have to define it here. So it will be int star and int star, because it is taking pointers. It is not a value thing. Let me run this thing, and we can see that I have called the function. All things have been done inside the function, but whatever happened here is being reflected in x and y. I am printing the value of x and y. Fine. This has been reflected. So x becomes 20, y becomes 10. If we don't use pointers, x and y remain unchanged. All the processing happens on a and b. But because of pointers, we are manipulating, we are working on the original values x and y, because this means the value at a, that is the value at a is this x thing star p. So this is a clear example which shows how useful pointers can be.